Hello, welcome to Flipped. So today we will learn to identify positive ions, which are called cations. So let's begin. So this is a mind map that I've drawn for you. Okay, and it's a bit messy, but actually it's quite easy once I go through. Okay, let's begin with the introduction. So to actually identify positive ions, which are called cations, you either add sodium hydroxide, which is NaOH, or aqueous ammonia, which is NH3. Okay, and we observe the change after we add them. Okay, first one, okay, we always, for example, using this one, okay, the left-hand side one, which is adding NaOH. So we always start off with adding a bit of NaOH, and then we increase the intensity. Okay, we add excess NaOH, which means to add a lot of it. Okay, so let's begin. So with this one, okay, we have an unknown cation. Okay, what we do is we add a few drops of NaOH, sodium hydroxide, and we observe whether it becomes colored or white. Okay, if it's colored, okay, then we add excess NaOH, okay, and it becomes this one. This block here represents insoluble. Okay, this is the legend that I've drawn, and empty box means it's soluble. Okay, so back to this. If it's a colored PPT, when I add excess NaOH, it will definitely turn insoluble. Okay, means it will just remain in the solution. Okay, undissolved. And based on the color, I can determine what kind of cation it is. So if it's blue, it's Cu2+, which is copper. If it's dirty green, which means a bit of dark green, it's Fe2+, iron 2+. If it's reddish brown, okay, it's Fe3+, which is also iron 3+. Okay, so these are the colored, PPT means precipitate. Okay, these are the three colored precipitate you will observe when you use NaOH. Okay, moving on to the other side. If I add a few drops of NaOH, okay, and it turns white, okay, and then I add excess NaOH, okay, if it's insoluble, okay, this colored box here, it's definitely Ca2+, calcium 2+. If it's soluble, okay, it's Al3+, or Pb2+, or zinc 2+, okay, aluminium, lead, or zinc, okay, and that's why this is not a very conclusive test, okay, the NaOH test, because when I have a white PPT, soluble in excess NaOH, I get three possibilities, okay, aluminium, lead, and zinc. So a better way would be to use NH3 directly. Okay, let's take a look at NH3. So I have an unknown cation, same here, okay. I add a few drops of NH3, aqueous. When it turns colored, okay, then I add more. Okay, this one just means excess NH3. Okay, I add excess NH3, and now there's two roads. First one is insoluble again, like the previous one. Okay, then I see the color, oh, it's dirty green, so it's Fe2+. If it's reddish brown, it's Fe3+. So you notice that Fe2+ and Fe3+, they do not change on both sides. Okay, they are both colored and insoluble. Okay, colored, insoluble. Okay, when either doesn't matter whether you use NaOH or NH3. Okay, these two stays the same. Okay, but Cu2+ is a bit different. When I have colored PPT, precipitate, I spam this NH3, okay, in excess. Now it becomes soluble, okay, instead of being insoluble just now in the case of NaOH. So now it's soluble, and it becomes a dark blue solution, okay, instead of a blue solid just now. And this is because, okay, the light blue solid, okay, it dissolves in the excess NH3 to give a dark blue solution. Okay, that's why it's dark blue and not blue like previous. Okay, now on the other on the second half, okay, if I add a few drops of NH3 aqueous to my unknown cation, it forms white precipitate, correct? And then I just spam NH3. Okay, if it's insoluble, it is definitely either Al3+ or Pb2+. So you notice that either when you use NaOH or NH3, Al3+ and Pb2+ is always the same. Okay, you can think of them as they are a couple. Okay, they always stick to each other. So no matter what conditions you give them, okay, they are always together. If the white precipitate, you add excess NH3, sorry, and it's soluble, okay, it's definitely zinc 2+. So because it's white precipitate, and if it's soluble, okay, the white precipitate will dissolve in the NH3 to give us a colorless solution. Makes sense, right? Okay, on the other hand, okay, if it's a white precipitate, okay, But if you add excess NH3, there's no reaction, it's Ca2+. Okay, Ca2+ has no reaction with NH3. Okay, so this is a rough mind map to show you how to identify cations. Let's move on to the details. Okay, so this is the same as the previous, just that I presented it in a different format. Okay, let's go through. Cu2+ is blue precipitate with both either NaOH or NH3. And in excess, NaOH is not, it cannot dissolve. In excess NH3, it can dissolve. Whereas Fe2+, dirty green precipitate with both NaOH and NH3. Na is insoluble in both NaOH and NH3 excess. Similarly with Fe3+, which is reddish brown in color. Okay, is insoluble in excess NaOH and excess NH3. So with that out of the way, let's move on to the white solids, okay, the white precipitates. Cu2+, white precipitate with NaOH. Okay, no reaction with NH3. Okay, but when you add excess NaOH, it does not dissolve. Excess NH3 does not dissolve because it doesn't even react with NH3 in the first place. Aluminium and lead, I told you they are together. Okay, so they both form white precipitate with both NaOH and NH3. Similarly for lead. Okay, and they both can dissolve well in excess NaOH, but it cannot dissolve in NH3 excess. Zinc is a white solid, okay, with both NaOH and NH3, can dissolve both in excess NaOH and in excess NH3. Okay, finally is NH4+, which is ammonium. Ammonium I did not include in the diagram because it doesn't flow well. Okay, it's just something you have to remember without the diagram. And it's how to identify ammonium salts. Okay, is that when you heat the salt, okay, with NaOH, okay, provided there's heat, is important to catalyze the reaction with NaOH. Okay, you produce NH3. Okay, and when you produce NH3, you can be sure that NH4+ is present in the salt. Okay, in the solution that we're interested in. So NH3, how do we determine this? We will talk about this in the next video, which is how to test for gases.